Okay. Who's enjoying it so far? Got some good stuff out already? Brilliant. Thank you. That's wonderful. So what I really wanted for us to do today is to, everybody pretty much across the country is starting to think about the curriculum. Some people have sort of got a well-developed curriculum, you know, for computing, and others are probably more thinking about, well, you know, how do I change this? What do I tweak? What should I keep from my previous curriculum? Should I keep anything? You know, all of those sort of questions. And so what we wanted to do was get a few people who have sort of done some of this and just sort of give you some ways that we've tackled this. Now that's not to say that that will be exactly right for you. You know, like everything, every school is different, and every teacher is different, and every sort of situation. And we hope that you'll sort of take some ideas, and you know, good curriculum is you steal from lots of people and then make some stuff up yourself, don't you? Okay.
Leverage, I think.
Leverage, yes, thank you, Liz. Okay. Right. Now, one of the things that I find is that people always ask me, and I'm going to concentrate more on the sort of computer science elements of the curriculum, because, you know, if I'm honest with you, I think actually we often did a lot of the digital literacy quite well. And what I want to say to you is please don't throw out the baby with the bathwater. I have heard, I've been running training courses all across the country in the last sort of couple of terms, and I have heard some pretty worrying things from some people where consultants come in and said, right, you should just do 5% of your old digital literacy, your old ICT, and everything, 95% should be computer science now. Now, there's no government numbers on this at all. In fact, I was in one of the meetings with when we were working on the curriculum, and they actually asked the minister, you know, is there any sort of time issues on any of these sort of points for the Key Stage 2 or Key Stage 1 curriculum? And he said, no, all you've got to do is cover this stuff by the end of the Key Stage. Okay, so nobody from government is going to come around and say, look, you must do this, okay, or you mustn't do something else. Hello, Newcastle. Hey, actually, we have got some people starting to say, actually, hopefully we'll be able to work straight on them. So I think that's really important to say. Now, obviously, you know, even my percentages are just my percentages. All right, I tend to do in the schools I'm working with about a third computing science and about 2/3 digital literacy. And I tend to think that the digital literacy, where I'm going in as a specialist, the digital literacy is far better done by the class teachers, okay, in real situations and linking to the rest of their curriculum, like we were doing in the past, let's be honest. So please, yes, we might have to do some paring down and some cutting a few bits out and making some space, but please don't throw out those really good modules you've been doing already. Right, let's keep some of that stuff. If I had an ideal, all right, I would push a little bit more in the top end of Key Stage 2. All right, but that's, you know, that would be if I had my ideal school, and actually no one's going to give me a school just yet. All right, well, you know, give me time working on that one. Okay. Now, I want to do a little bit, before you can sort of do curriculum design, you sort of have to be able to interpret some of what's going on inside this. I do have a CS vocab page where we sort of explain some of the sort of vocabulary and what it means, and I would really encourage you to pick up a copy. Can I just steal that for 10 milliseconds? Thank you very, very much. Okay, that was, there we go, I'm back. All right, I would really encourage you to pick up a copy of this on the way out, written by Miles Berry. There we go. Okay, it's got a hideous picture of me inside as well. That's not the only reason I'm encouraging you to pick it up. Okay, but it has got a really good CS explaining some of the vocab page in there, and it's well worth reading. Miles does have a really nice writing style, I think. Okay, and thank you very much for that. Sorry to steal that. So, let's just have a little look at some of the sort of interpretation. I can see the people at Newcastle look, where has he gone? Come back, Phil. Brilliant. Okay. So, things I think are really important to actually understand and get, first of all. Do you know, the funny thing is, the thing I think that is actually the most important is this area of debugging. Now, a bug is It's just something, an error in your code. Okay? And actually, it's probably one of the most important changes. In all the schools I've been working at, I have found this sort of, and I think it comes from the busy teachers trying to squash 45 minutes of digital literacy type lessons in, and you get to the point at the end of the lesson where you know that 6 kids are not going to finish what you need them to do. And the next lesson you might need that in history, or you might need it in literacy. So we get to that point of actually just telling children what to do. And actually I've seen a sort of a block of children across all the schools I work who are just into this sort of, don't get it, Mr. Barrow. And it's not that they're just passive. They've been taught and trained by the teacher to some extent, all right, to actually not fix things themselves, to not even try sometimes, but just to wait until the teacher sorts it for them. And actually, the computing science elements of this curriculum that's the total opposite of what's important. It is actually, I say this to children in the first 2 lessons of every single sort of block of work I do that's got any sort of computing science aspect to it. Every programmer makes mistakes. Okay? And mistakes and debugging is just a normal part of what you do with this. Okay? You've got to get that over to children, that it's totally okay for them to make mistakes. And I've actually seen children literally go, okay, that's cool. Alright? And it's also not your job to fix their code or their algorithm problems. What do you mean, Phil? What, we're just going to leave them to get on with it? No. There are some strategies and things you might be pointing them towards. Alright, but you have to actually slap your hands and actually not fix. It's been interesting working with teachers. That has been the most difficult thing to train people out of. That sort of, I just want to go and fix your little problem that you've got. And actually you really mustn't. Because actually you are totally de-skilling them if you do that. Funny thing is, we're brilliant at doing this in literacy and maths. We're not too bad in science, but we're absolutely awful when it comes to ICT. Okay, mainly because we've had time constraints in the past and we've tried to get things finished in time. We need to liberate pupils into messy problem solving. Okay, and the coding aspect of this and the computing aspect of this is the ideal place to do this. Alright, and it's really important that you do. So actually, although there's all sorts of other challenges for the curriculum, this is actually the biggest challenge to get over to teachers in your school. Alright, and this is probably more important, I think, at the early stages than all the other stuff. Okay, sorry, I've laboured that one. I think it's also important to understand the relationship between an algorithm and a program. Now, we've got the idea of an algorithm, just a step-by-step guide, okay, a precise step-by-step to actually accomplishing something. Okay, that can be as simple as setting down my cards on a Bebot route before actually using that Bebot and checking out and see if those instructions work. Okay, it can be just writing arrows on a whiteboard for logo type instructions. Okay, so all of those things. But what we need to understand is actually algorithms and programming are related. They are all part of problem solving. Okay? An algorithm is very much normally written in everyday ordinary language or maths. Okay? But it's a step-by-step instructions to doing something. A programming is an algorithm, but it's written in a programming language. And you get a massive crossover of some programming languages. They're actually a lot closer to what an algorithm is as well. Let's give you an example of something like Scratch. Well, Scratch, if you can read the blocks across and you can see exactly what it says, it's a lot closer to what an algorithm is. Okay? Because it's written in everyday language. At the point it says, move 10 steps, okay, turn right 15 degrees. Well, I can read all that, and it makes perfect sense, okay, in English as well. So it's a lot closer to that. So once we've got an understanding of that, we can interpret some of the other parts of the curriculum. Okay? Now I tend to think of my Key Stage 1 This is most of the Key Stage 1 computer science element of the curriculum. And I tend to think of this as a programming burger. Okay, well, you know, we talked about takeaways earlier, all right, for those who are in my session. So you can see that I do like the food. What do I mean by that? Well, actually, there's a meaty bit in the middle of this. And the meaty bit for me is create and debug simple programs. And remember we talked about the relationship between simple programs and algorithms? So I would put algorithms in there as well. Okay? And these other bits are like the supporting bits that help us to understand what we're doing when we're creating and debugging simple programs. Okay, the understanding what algorithms are, using logical reasoning, all of these things are supporting bits, all right, that help us when we're creating and debugging simple programs. Do you know, I'd also take my food analogy into Key Stage 2 as well, where I have the programming sandwich with internet side salad. Okay, now the earlier session we did on the internet side salad. And by the way, that session will be videoed. I think it was videoed, and we will stick it online if that's useful to you in the future. Yeah. Now, let's have a look at this top bit then. Design, write, and debug programs, algorithms, that accomplish specific goals. Okay? And then we've got all of these other bits which sort of tell us about that and support that. Okay? Including controlling or simulating physical systems. Decomposing them, breaking it up into really small bits. Okay, using sequence selection and repetition in programs. Okay, working with variables, various forms of input. All of these bits are about how and what we should be doing when we're programming and when we're algorithm creating as well. Okay, and I think it's worth just sort of understanding that. I would also encourage you, I'm starting to see people out there who are saying things like, oh, we've done a repeat loop. Oh, we can tick that off on the curriculum. We've used a variable once. We can tick that off on our curriculum as well. Please, 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 please. These are simple ideas, all right? But when you put them together in lots and lots and lots and lots of different ways, they're also incredibly complex ideas as well. And don't let anybody tell you that just doing something once, all right, is covering it. Okay? So I put here not things to tick off on a chart and say you've covered after one use. Right, children need repeated practical experience of writing programs, writing algorithms, of debugging them, all right, of fixing them, of working them, decomposing, thinking them through, okay, which use these things. A complete and open language will use all of these. And in fact, one of your key tasks is you deciding what are you going to put in your programming curriculum, or sorry, in your computing curriculum. Okay. One of the things I would encourage you to do is to look at, well, how much of these things does it use? Okay. And in fact, one of the reasons that I promote Scratch very heavily is because actually Scratch uses all of those things and uses them really, really well as well. Okay. It is how they are used, not if they are used, that determine their complexity. All right, and that's really important. I can do there's Logo uses these little sub-programs, okay, called procedures. Actually, they're not mentioned until Key Stage 3 curriculum. But in Logo, they're perfectly good and brilliant, and really, really, I use them. Okay, because the children can understand what they're doing. If I was using something like that in a more advanced sense, it would be a lot further up. So it depends how something's being used, not if it's being used, as to the complexity of it. I would encourage you, especially early on, all right, to choose one main programming language and dip into others. Mainly, there's two reasons for this. We've all got a training issue in terms of training other teachers in our school. Okay? If you hit hundreds of things, now of course if you're the specialist in your school, I think that's great. You know, and that's fantastic. But actually if you're training everybody else, it's often a really good idea to stick to a few things and do them well, at least to start with. You're more likely to take people with you. Okay? I have here this on my website. This is my view, my personal view, on some of the programming software and its sort of best fit, okay, for the different key stages. I'm not a big lover of things like Espresso and ToCode. I think that some of these things are being sold as a solution to the computing problem. Okay, and I think, and where I see them being used well, people dip into it for a lesson or two and then go and do something a bit more open-ended, and that's great. But it does worry me that some schools will just buy into this, okay, and they think, oh, I've done programming or I've done computing at this point. Okay, and I would really encourage you to avoid just going down that easy route, really, because I don't think it actually leads you to the really enjoyable, open-ended type activities that the children will really get into. Okay. I'm going to hang my hat on something, and my hat probably is pretty firmly hung onto Scratch, and it comes from actually me doing lots and lots. Most of those other programming stuff I had tried in school. Okay, a couple of years ago I approached a load of Hampshire head teachers and I persuaded them to let me teach in their schools, and I have tried all sorts of things. And I have made some horrendous mistakes along the way as well. Okay, and what I have come up with is that I think Scratch is really excellent and well worth investing your time in. Why? Because it uses sequence, selection, repetition of variables well. Okay. It also is great for creating a variety of programming types. If what you're creating is always about games, then you buy in children who are only interested in games. Now, I love gaming, I really do, and I think it's a fantastic, exciting, do some really interesting modules in Year 5 with Scratch gaming. Brilliant, really enjoy it. But I know some children who are not interested in that and actually would prefer to write an adventure game in Scratch, or would want to write a quiz. We do some maths programming through Scratch as well. I was really interested to see, we had a reporter come to the school, and you know what it's like, they always choose the children that, you know, you're thinking, oh my goodness, why have you chosen those three? Okay, and they went out, and I had no say over anything really, because I was teaching at the time, and actually, what did the kids go and show? They went and showed all the maths programs we've been making use of Scratch. They were really proud of those, and it really surprised me actually. I came back and I thought, actually, let's not belittle what children enjoy. Sometimes I ask the kids, and it's sort of cleverness sometimes of something that they like. Oh, I can see this, I can see how it works. So Scratch, I think, is brilliant. It's free. There are 2 versions of it. There's an online version that has its own community. All right, so the children, I have children in Year 5 or 6 who are going on, and they, in effect, they do the flipped classroom, really, because they work on their own projects home, and then they come back into class, and they carry on in class. And then I work with the rest of the children who are not so interested in that. Okay, and they love it. And some of them use the Scratch too, and the rest of the kids tend to use the older version, because in my opinion it's just a little bit easier. Okay, I do keep the older version. I haven't moved everybody onto 2, because for the younger children I find it a bit easier, but that's me. Okay. And I think there's a real depth to Scratch. You know, you can do things all the way from Year 2. Okay, who am I to say? I mean, there might be people doing things even lower than that, but certainly I know teachers in Hampshire who've done some good stuff with Year 2. All right, and I know some undergraduate degree courses that use Scratch to introduce a strand of programming as well. Okay, I was looking to Les Carr there for a nod in the right direction. Thank you, Les Carr. The guru of web. Just the web. All right, shut up. Move on. So, let's just talk a little bit about the phases of programming. Okay, what can it do? And I'm going to sort of use Scratch as a sort of explanation of things that I do with the children. One of the things I do is we often show, especially in the early stages, I believe that children actually have to see what it can do before they can reuse it. So often we make some little projects to start with. And one of the things I often do is I show them a working copy of a program. I don't show them any code, all right, and I get them just to tell me what type of things am I going to have to make and what type of things am I going to have to make it do. Those are my 2 questions. And the kids will just, something like this crab game, they will say, oh, we've got to make the crab. Okay, and then they'll say, oh, we've got to make the background. we've got to make it steer. We've got to make it move. We've got to make it touch those coins and collect the points. So we're not really getting into anything about programming at this point. We're just talking about the elements of the game, all right, that they're going to need to make. And then as we make those bits, we can refer back to the bits that they've decomposed and thought about it. Okay? I often give the children the blocks of Scratch. By the way, does anybody here not know what Scratch is or not even had a look at it? One or two. Okay. I would encourage you to go and have a good look, download it and have a look. Scratch is a block-based programming language. So you can only snap into place certain blocks and they'll only work in certain places, which helps children because there are some blocks that won't attach to other blocks, which makes it easier. I will often give the children some of the blocks and I won't actually put them together in the early stages. I'll say, okay, we want to see you go and have a go at finding those things, snapping them together, click the green flag, does it work? If it doesn't move that thing across the screen, then go and redo it. Because I want the children to get into this understanding that it's totally okay to make mistakes. Okay? It's funny, when I'm teaching teachers, the kids get into this in seconds. But sometimes when I'm teaching teachers, I will have teachers go, oh, I've done it, it's not worked. What do I do for? What do I do for? You re-pull the blocks out and reattach them in a different way and click green flag again. But, you know, so it's a trial and error thing, okay? Trying different bits in the early stages. I often get the children to read the blocks as well. Sometimes all with me, and sometimes, okay, when they're trying to debug things. Because actually, when they read it, they often realise that there's a problem with it. You know, because it actually doesn't make sense. All right. One of the disadvantages of Scratch is it is possible to copy bits without totally understanding. So if you get the children to read those bits, that helps a lot. Okay. I also often will give children a similar example, but not exactly the same. So I'll give an example. We were doing a little bit of maths program where we're making a program that works out the perimeter of 2D shapes. Okay, I've done this in year 4, 5 and 6, depending on the children. I will often give them an example of the radius of a circle, and then I'll give them that grayed out, and I'll get the kids to talk about it and write on top of it and say, how would you change this to make this work for the perimeter? So we're not just giving them something, we're giving them similar and making them think about how they would adapt it. Interestingly, when I've done this approach, I've had loads of children being able to go and adapt it and change it later. The next up activity from this, and this is on my website, it's one of the modules of planning, okay? The next up planning for this was to adapt this and do a rectangle. So of course you need more than one variable. Loads of kids were able to do that because they had to think about the original example, okay? Which was useful. Modelling physically. I'm a big believer, especially if it's a game and things are moving around, to actually model this physically. You know, Les, I'm going to ask you in a second to go and move this and follow me round as I do it, so people can see what I'm doing. So what I'm going to do here is just model this forever loop. Okay, so anything inside here gets repeated over and over and over and over forever. Okay, and we've got move one step and point towards a mouse pointer. Now, can I have somebody to be a volunteer mouse pointer? All you have to do is walk around slowly in this area over here. Can anybody do that? Hey, sir. Oh, brilliant. Come on down. Okay, so all we're going to do is just model this. And actually, there's a lot of Scratch that you can model physically, and it helps the children to understand what's happening. So I am the sprite, and you're the mouse pointer. All right, so all I'm doing here is, because I'm in a loop, some of you will say, Phil, you're in a loop anyway, but it's another issue. I move forward one step, and then I point towards the mouse pointer. Now you can move at this point. So I move forward one step, and I point towards the mouse pointer. And I move forward one step, and I point towards the mouse pointer. And I move forward one step, and I point towards the mouse pointer. And I move forward one step, and I bang into the table, and I point towards the mouse pointer. Now, when you... Thank you. Big round of applause. Now, when you're doing this with children, I have found explaining the forever loop using that physical type modelling really, really, really useful. When we then talk about, oh, we've done this somewhere else, and we want it to get checked over and over again, they go, oh, use the Revolut, Mr. Mayor, use Revolut, because they can see how it works somewhere else. Okay, so I think the physical modelling of things is really, really important. I also have some bits on my website which you can go and have a look at, where we link to examples of coding which are not about actual coding. So there are examples where we link things to everyday usage. But you go, I haven't got enough time to go into those, but do go and have a look at those as well. I also really encourage children to tinker. Okay, and I don't know whether that's the right word.
Play.
Play, thank you. Adapt. Try different things. What do I mean by this? I mean that actually I want children to, yes, to build different parts of this, but to go, oh, what does this block do? And put it in there and try it out. And I will often find children, they'll do a little bit that we've done, and then they'll add extra bits in there as well. Okay, and I think that's brilliant. And I will encourage children, and I won't say, oh, don't know. And it's very tempting sometimes as teachers to want them to do exactly what we want to do. And yet, now, I will have a little deal, I might say, we're moving on to the next bit of programming now. I would encourage you to take those blocks out, because they might muck up your program for later. But it's really, really brilliant what you thought of. Okay, just encouraging them to actually take a bit more control and get away from this sort of passivity. On the plan, you'll see we've got lots of extension tasks. One of the things that has really rescued me with all of the programming has been these extension cards and extension tasks. So what I do is when children are finished, they come up and just ask me for an extra extension task. And we will go things like, okay, can you make it go faster? Can you make it go slower? Can you make it go backwards? And they'll always often go and try and adapt their code. All right? And those are really, really useful that bind children in. And they're also encouraging the children to adapt what you've done and change things and move on from just what you've done as well. I also use support cards. Let's be honest. Most lessons, you've got some kids out on boosters. You've got kids who turn up late because there are other things. Being able to say to a child, oh look, here we go, here's a sample of code. You know, go and see if you can make that. All right, while we're concentrating on other things, really, really does help. Or, and I found this with some children, we get back to this debugging, you know, so we're saying, Mr. Mayor, it doesn't work. And I say, okay, have a look at your code. Have you compared your example to the little bit of code the person sitting next to you? Have you compared it to what we've done up there? Can you spot what's wrong? Okay. Some SEN children I found don't always see that if it's too far away. So having the piece of code in front of them on a card that they can compare it, I found a lot more success with. Okay, and they're oh yeah, I can see that, and I can move on and I can adapt. Okay, and change and debug my own work. And then of course they debug doing so. I have debugging stickers. Okay, so you fix something, you write your name on it, you stick it on the wall, we celebrate you fixing it. There are some children who debug stuff just because they want the stickers. Do I care? No, because they're into the idea that it's totally okay to make mistakes and fix it. Woohoo! Okay. And then I go along a little bit further, and this is more about adapting and using what they've learnt before and what they've come up with. Okay. By the way, very little programming starts from nothing. I have tried giving children something and saying, right, just do this from nothing. Okay, and I have bombed spectacularly with it. Right? And actually, most programmers start from the base of something else, and then you adapt it and modify it. Okay, and that's cool. Now there are some kids who will be able to start from nothing, but you know. So what do? One of the things we do to start with is we will make a base idea. We will have this little idea. We'll have the basic code for this. We'll talk through how it works, and the kids will make that. And then what we do is we go outside in the playground if it's nice, we take some chalk out there, the kids work in 2s and 3s, okay, they draw on the playground or they physically model it and they think about what they'd like to change and adapt and make different. Alright, and that actually I think that is just a brilliant opportunity to think about. So in this case it's a platform game. If we go back, there's a little platform game that they've seen the base of this, okay, and then they're thinking about how can I take that on? Actually, children play loads of games. They will have no difficulty in finding things to adapt and move on and change and make better. Okay? Then, we come back into class and we use this decomposed game plan. And all this is the children write their idea down in the middle of this. Okay? And then they circle the different elements, and they take those elements out, and they expand and explain what they want them to do. Now, I've got to be honest, the first time I made the children do this, they were like, oh, there's no want to go and do some more programming. But actually, it really does work to do some good planning beforehand. It really does work, and I got a far higher quality of work after actually making them do a little bit of planning and think about it. And then we took it out, and there's one more layer of this, okay, around the outside, and they take that out and they think, well, what scratch bits that we used in the past that we could use? And we also have a little scratch primary games thing, okay, which has some other ideas. That's the little block in the middle, which is also on the website, okay, that the children can have a look at some ideas. Oh, I want something to fall all the time. Well, there's an example of how gravity might work in there. Or I want something to move across, or I want something to change. There's some examples of code. They won't be able to just copy that. They'll have to muck around with it to get it to work. Okay, muck around with it. They'll have to adapt it. Repurpose it. There we go. And just some things that are useful for you. Okay, where could it fit in? I mentioned that previously. Okay, I have a complete scratch plan. I'm always changing, I'm always adapting things. I'm always changing bits. All right, as I discover new ways of teaching it. Okay, and there's some idea of scratch progression. That's a work in progress. I did that quite a few years back, but it is still there. Yeah, I've got a few more minutes. Just as importantly, not all computer science needs to be programming. And not all computer science needs to be on a computer either. And actually, the first time you sort of explain that to the kids, you can see them, they're sort of drawn to the ICT suite or the laptops, and they're like, I'm going to get my laptop or my fix. But actually, when you do some really fun stuff with this, you buy them in. Okay, things I do, I have a jam sandwich making. Who's seen my jam sandwich video? I'm not going to show it to you. Okay, it's really funny. I think I've probably seen the jam sandwich video. I've been tweeted more about that than any single thing. In fact, frankly, I'm sick to death fed up with the jam sandwich. But actually, it's brilliant for kids. What is it? Basically, we say to children, right, you've got to program your teacher to make a jam sandwich. Okay, and they look at you with disdain in their eyes. What is his problem? And then you say, well, actually, as they start to do it, they realise it's actually really difficult. And you have to be very precise. And you, as the teacher, have to be very pedantic in your interpretation of that. Okay, you only do exactly what they tell you to do. Okay? But do go and have a look at the outtakes video. Don't show it to your class, but do go. The outtakes video is hilarious. Okay? But it's on there, it's on the website. Another thing that I've been doing quite recently, I love the idea of flow diagrams, but I actually think children need to use a flow diagram before they can write it or create one. And actually, one of the ways that I use to get children into this is actually I've got some playground games, and I don't tell them what playground game as flow diagrams. And all they do is I give the sheet to them, 3 or 4 kids, and I say, right, go and play this game and work out what it is. And actually, all I say, I don't go into anything about what the different blocks mean or decision blocks or anything. All I say is, you've got to start from start. And actually, the kids love it. I've done this with Year 3 and Year 4 kids, and they love it. And they go away and they play, and you can see them talking about and discussing, oh, we've got to go and do that. Oh, what game is this? And they're working out. And Year 3 had no problems at working out. We had a few kids with reading issues. That was probably the only thing in Year 3. Okay? Then we take it a little bit further, we take it back into class, we nick all the good copies back off them, and we say, well, okay, I've got some bugged copies. Can you work in 2s or 3s to work out the bug? Do you know, when I first did this, I thought, actually, I don't know whether the kids would work it out. I had, especially in Year 4, I had loads of the kids, you know, and the discussion between the 2 or 3 kids trying to work out what the issue was, and then they were working out different strategies, and they'd say, oh, I'm going down the yes and you're going down the no, and they could tell me all these different strategies they were using to try and work out where it went wrong. And actually, in a class, in 20 minutes in a class in Year 4, there was all but one group of 2 kids, all but one group solved at least one of those, and some groups went on to solve 2 or 3 of them. I think partly because they had already used a working copy and had so much fun making it into a game outside. They were bought into it. And so at this point, they were really enjoying it. Okay? I'm actually writing some ones at the moment for things like Snap, making the blocks and seeing if we can get the kids to put them in the order that they fit. But I'll come back and tell you whether that was. And frankly, if you never hear from it again, it's because it was rubbish. We shall see. Okay. I also do a getting up algorithm with the kids. And this is quite fun. We just say to the kids, well, okay, we're going to use something like Publisher, and we just say, okay, you're going to do a set of instructions for waking up in the morning and getting to school. And you know, the kids look at you as, again, like you're mad, and then you say, well, okay, and then you get a kid going, oh yeah, wake up, go to school, no, wake up, have breakfast. And you go, oh, that's fantastic. So breakfast is delivered right next to your bed, is it? No, I have to get, oh, you have to go downstairs, do you? So there are actually some more steps involved in this. And actually, when they start working out, actually it's a bit more complicated than they thought it was. All right? So that's a really nice, useful one. And the planning's on there as well. And I think we've pretty much, for those people who came along to the session earlier, I'm not going to go on about this, okay, we do also have a strand of how the internet works and how networks work and how search engines work. And I do that as one block in year 5. I would do it in year 6, but year 6 is always taken up with more interesting things, especially programming wise. But that's just me. And if you didn't come to that earlier, that is available as a video on the back there. Right, I hope that's helped some thoughts. What I'd like to do now is hand over to John, who's actually got a different perspective on this, and thank you.